Alright guys, so I just realized that there were a few questions on the review that were recorded, or the audio was recorded, but there was no video because your physics teacher made a mistake. I apologize for that. So here's number 10 and 11 on the electricity and circuits review. Number 10 says that we've got a 10-watt light bulb that's plugged into a 120 volt outlet, and I want to know the resistance. So I want to solve for R, and I'm given V, and I'm given P. Now, we've done this type of problem multiple times, and you realize that there's no equation that says P equals V times R or V equals R times P. So what is missing? Well, I noticed that all the letters are here except for current. So that should be your indicator that current is what needs to be solved for first. So if I have power and voltage, I can find current using my P equals I times V equation, where P is 6, I is unknown, and V is 120. So if I want to get I by itself, I move 120 to the other side, and I get 6 divided by 120, which gives me I, which gives me 0.05 amps. Now I found I, but my goal is to find R. So now that I have I and V, I can solve for R using V equals I times R, where V is 120, I is now 0.05, and R is unknown. So if I want to get R by itself, I divide 0.05 to the other side, and I get 120 divided by 0.05, which gives me R, which gives me a value of 2,400 ohms. Number 11, I've got a 6 kilowatt generator that's powering a cell phone for 30 minutes. I want to know how much energy is used. So I want to solve for E. Now this is electrical energy, so we're not measuring it in joules, we're measuring it in kilowatt hours. So this is my time, and 6 kilowatt hours, this is P, power, electrical power. Well, I know that electrical energy is power times time, but my unit for energy is kilowatt hours. So my power is already in kilowatts, but my time needs to be in hours. Here it's in minutes. So how do you convert minutes to hours? Well, take 30 minutes divided by 60 minutes in 1 hour. That gives me 0.5 hours. So that's my time. So energy equals power times time, which means that energy equals 6 times 0.5. And when I multiply those two together, I simply get 3 kilowatt hours as my electrical energy. Okay, so just be aware that if your answer is to be in kilowatt hours, your power has to be in kilowatts, which it is, and your time needs to be in hours. So to convert minutes to hours, you take the time in minutes divided by 60 minutes that are in an hour, and you get half an hour. The next couple questions that I want to discuss, because they were not on the video originally, is numbers 23, 24, and 25. Okay, so 23, 24, and 25. So number 23 is describing the circuit that's here on the right. So you're asking to figure out, or asked to figure out what type of circuit this is. Well, this is my power supply, and I trace my pathways. I can go up and down through resistor 1, that's one pathway. I can go up and down through resistor 2, that's the second pathway. I can go up and down resistor 3, that's 3 pathways. There's more than one, which automatically makes this a parallel circuit. And I know it's a parallel circuit because it has multiple pathways. Okay, and it has 3 to be exact. So if I'm looking at this circuit and R1 goes out, meaning this resistor right here goes out, maybe the light bulb burned out or you unscrew the light bulb, whatever it may be, what's going to happen to the other light bulbs? Well, I know that this is a parallel circuit, and electricity, electrons have more than one pathway to travel. So if R1 goes out, this is still a closed circuit. Okay, electrons are still going to move. and they're going to move through, they can't go through R1, so they're going to move through R2 and back. They're also going to move through R3 and back. So the rest of the light bulbs here are going to continue to work. They're not going to change. And at 25, I want to find the missing resistance. So I'm looking here and I see that I know the resistance of R1. I know the resistance of R2. I want to figure out, I know the resistance of R3, sorry. I want to figure out the total resistance. So what is the total resistance here? How do I find total resistance in a parallel circuit? Well, I know that it's not as easy as adding them up because the resistance actually decreases in total as you add more resistors. So you're adding the inverse. So it's the inverse of R1 plus the inverse of R2 plus the inverse of R3, all inversed one more time. So if we plug in some values for all of these R1s and 2s and 3s, I get the inverse of 6 plus the inverse of 12 plus the inverse of 18, all inversed one more time. When I type that into my calculator, I get a total resistance in this parallel circuit of 2 ohms.